Hi friends, this video is on a topic that I've kind of touched upon in multiple videos, but this is more in depth. So I'm going to talk about Siluriformes, which is the order that encompasses the name catfish, and it contains your plecos, which are your Loricariidae, Corydoras, which is in the family Callichthyidae, along with Hoplosternum, Megalichthys, Callichthyidae, Leptoblosternum and Dianema. Oh, and there's also others like Aspidoras, Scutellarium, Mystax. There's plenty of different examples. In the freshwater fish keeping hobby, we have the luxury of access to fishes that come from all across the world. Siluriformes are no exception to this. Species are found on every continent, both native and invasive. For example, Untitled are native to North America. So this is your bullheads, Amurus, Ictalurus, and also you have Silurus of Eastern Europe, and that is the only native Siluriform to Europe that I know of. But both are actually found invasive in quite a few different regions. We have Silurus in the UK as an invasive species, but also farmed. There are also Ictaluridae kept in UK. I believe there is licensing involved, but they're farmed in some places, such as Sparshot College in Winchester. There are also marine Siluriformes, for example, Aridae and Plotosus, which are some actually quite complex, highly venomous fishes, but Aridae, for example, quite a few members of them that are marine, they started from freshwater habitat and then slowly move into marine one. And for Plotosus, they are fully marine, and you'll see them, they're quite striking. They are now banned in the UK under EU legislation against invasive species. So they're found sort of around Oceania, all the way to Japan. And they are sort of very striking, striped, white-black stripes, shoaling as juveniles and becoming less social when they're younger, but you used to be able to get them in the trade quite easily. Many more will exist in brackish environments, so this is the sort of area of salinity between freshwater and between marine. So this would be like Platystachys cotylophorus is found in a brackish environment. But the majority of Siluriformes are freshwater, and this is what we mostly associate with them. Those that are invasive, you've got Plecos, which is found across the world, is native, as all Loricariidae are, to South America, but is found in Asia, Africa, Europe and North America. Whether there is a sustaining population or very temporal or temporary is difficult to say. Silurus, as I mentioned before. Claridae is native to Africa, depending on the species, but they have been found in Asia and North America. I've never seen them in the UK. Claridae is mostly really known for being, for the walking catfish, which I think is Clarius batratus or something. And they're all quite similar, really, the Claridaes. There are also parasitic Siluriformes, and there's also electric Siluriformes. There's the electric catfish. I cannot remember its scientific name, but for parasitic, there is plenty of selection of different parasitic Siluriformes. There's a Trichomyceridae, is the family that contains the Candiru fish Vandellia cirrhosa, which is the one that's known for is reported to swim up the urethras of people. But other members of that family can be parasites that predate. Other members can predate specifically on very niche things. So some are specifically scale eaters, some are specifically ones that only go for fins, and then you've got even more unusual predatory catfishes. So you've got Cetopsis, which is in a different family altogether, and Cetopsis is known for stripping flesh off dead organisms with quite sort of keenness. Some Pymnidae are known for this, and they basically do what piranhas are meant to do, but piranhas never do. They are kind of a bit, not particularly active, but I wouldn't want to get on the wrong, like get in the waters with them. I wouldn't trust it. There's papers and like footage of them stripping flesh and bone quite rapidly, and they're found at extreme depths in the Amazon River. So there are currently 3,466 currently described species of Siluriformes according to Catalogue of Fishes, which is by Dr. William Eschmeyer. And this ranges in sizes from only a few centimetres all the way up to 4 metres, or, well, it's debatable recorded sort of things, because some catfishes that are in the running for the largest freshwater fish, such as the Mekong catfish, which is the Pangasiidae, Pangasius gigas is the Mekong, but other members are particularly large of Pangasiidae. You also have Silurus glanis, which is the world's catfish, and that can reach 4 metres. So they can be tiny or they can be large, and it's such a diverse taxa. We do find many species in the trade, but many families are still largely excluded, and apart from the rare bycatch, you probably won't see them, and many are really hard to identify to a species level. Especially I find Trichomyceridae I can never pronounce that. So with this diversity and a really extensive range, Siluriformes are adapted for a wide range of habitats, and their habitats are often reflected in their morphology, and the water perimeters are best to research and try and match, but not just the perimeters but other styles of their habitat, because there's more to a habitat than what's in the water. Otherwise, say if you're trying to keep a mammal, you're just trying to alter oxygen levels to match it if you were doing it, say, that way. But in water, you are actually altering and looking at what the water perimeters, which is kind of equivalent to looking at the atmosphere. And then you're also doing the habitat, which is a really important thing. So water perimeters. Water perimeters refer to the actual type of water present. It refers to set conditions which are often linked. I'll attach a link to a Facebook group where I've recorded like an Excel document with like set perimeters in scientific papers, from scientific papers, and this can help you. I couldn't find any that listed KH or GH, and this is more for South American water bodies and the African water bodies, more the lakes in Africa rather than, say, the Nile, the Congo. But it's worth reading and then researching yourself. There are papers around. Some are a bit more difficult to find than others, and some, like especially tropical regions, tend to be very understudied in terms of their geography, whereas temperate regions, such as we know a lot about Loch Ness, Lake Windermere, and their ecology, the ranges and the parameters depending where you are in the lake, whereas when it comes to tropical places, they are mostly understudied. But I will only really be talking about the parameters I can find reliable references for, but they are linked to others, so you can kind of estimate. I will include a range of tolerances in the document, so that means that the range varies on depth and seasonality. So if you read the paper further, it will explain which it's doing, because otherwise I'll just be writing this massive document which is a bit more complex, and it's not as easy to quickly point out something. And a range of perimeters that a fish can survive in, but there is also the range that the species will thrive in. So keep it within that range, but understanding the importance of lower temperatures, sort of a wintering resting period, is quite important. So firstly, temperature. Temperature is often recorded in Celsius. In scientific papers we use the metric system, so we do not use imperial or Fahrenheit or whatever. I have never needed to use the imperial system, and certainly not the American one, because not everyone, like most countries aren't the USA, so some things are more specific. Yeah, so for science it is metric mostly. So there might be variances between different members of the same family, genus, or even within the species. So it's important to recognise that, like, looking at the locality of where the fish comes from and then matching it based on that. For example, Siluriformes are found in North America. They can tolerate much lower temperatures, easily below 15. Not all are tropical, so this is a great example. As can Silurus species. So there is a Japanese species. I've never researched them due to both being banned here. But there are many species also in the tropics, and the marine species also vary themselves with temperature. Plecos is found in temperate and in tropical regions. But the tropics is where Siluriformes really seem to show their diversity. You've got Loricariidae, Callichthyidae, Asperinidae, Loricariidae, Morphology. That is really butchering that pronunciation, but that's the Synodontis family. And you got a lot, Bagridae as well. And yeah, so there is a lot of tropical ones, but even within the tropics there is a range of different temperatures. So you might think, oh, they're tropical, I'll keep them at 25. No, you can't just do that. So you've got stuff like the fishes of the Rio Xingu will be 28 to around 34 degrees centigrade. This will vary seasonally and on depth. But it's important to recognise that they're going to want those higher temperatures, whereas many tropical regions, such as Corydoras, are found in cooler waters. They're want about 18 to 25 C. And I would not say they're temperate per se. They prefer tropical, they live in the tropical regions, but quite a few of them have more temperate temperatures. So next is lighting. So this is really, I'm going to talk about a lot later, and most catfish do prefer lower lighting, and I'll explain why later. Velocity, again, it is in regards to their morphology, and this is important, well, really important for Siluriformes. Dissolved oxygen is very much related to velocity. A fish that's going to want high velocity is going to want higher dissolved oxygen. And the higher the better in general. You can get away with it. So an increase in salinity and temperature will reduce the dissolved oxygen within the water. That means that the fish won't be able to take up as much. And the more fish you have, the more they're competing for oxygen. Also, they are competing with bacteria and everything else. Some species are more tolerant than others, and this depends on where they originate and even within the same genera. Claridae, for example, will be more tolerant to lower oxygen levels due to the fact that they can absorb atmospheric oxygen, which is gas, so from the surface when they're on land. And they could take this in, I believe, in their gut, their stomach or intestines area. Callichthyidae are also similar. They can take in atmospheric oxygen, hence why they come to the surface and come back down. And then many fish are adapted for rivers' fast flow, such as Encistrus ranunculus or Hyperencistrus zebra, and they're going to be not very tolerant of low oxygen. You can get some Loricariidae, quite a few Loricariidae can take in atmospheric oxygen, but they do prefer higher flow anyway. It's better to make the fish thrive rather than just survive. So next I'm going to look at measures of hardness. So hardness is sort of like, I always say, like lime scale and stuff is related, because when most people see it through their kettle, stuff like that, when they're showering, lime scale, scum on the water surface. So it's really difficult unless you keep fish or you're working with like sewage or something. You might not know really much about it. So I always go by this measure that no one really seems to use, but unless you use RO, and it is probably one of the most important. So this is TDS. It means total dissolved solids, and it refers to the amount of solids within the water. So this incorporates a lot of things. So this is a big picture measure. It allows you to see if there's a spike, a reduction, a peak, and then you can narrow it down to what it is. And it's a quick measurement, it's just with a meter. So this does include factors like carbonates, nitrates, magnesium, and therefore it is measuring what so it's measuring what the others are and everything, if you get what I mean. Next is conductivity. It's similar but not the same. It is also important, and I could say you can measure either really. And this is also a meter that you just put in and it's very quick. So this is related to the water's ability to pass electric current in. So this is a concentration of ions. If you are wanting to keep sensitive fish, it could be beneficial to read both conductivity and TDS. But it really depends. Most fish you shouldn't really need to. Although it would be beneficial probably too. pH is kind of not always seen as important. This is the measure of OH and H ions within the water. Simply put, a measure of acidity and alkalinity. It is in a logarithmic scale, so this means that each number is 10 times higher or lower than the one previous or after. It's also not often recorded in papers, but is sometimes. Conductivity seems the most common over TDS, but you can kind of convert or relate conductivity to TDS. I find that usually if you halve the conductivity, I think it is from memory, that will give you a vague TDS, but still it's better to test both. So salinity, this is really important if you look at keeping the brackish ones, the ones that are migratory. So this is the presence of salt and how much, usually in reference to marine salts, which is the NaCl, which is sodium chloride. Yeah, but there are other compounds known as salts. Salts is a category. So you have Epsom salts, which is magnesium chloride, I think. So it will vary. This is usually best done with a, not hydrometer, but it's a little thing you like look through. Haven't needed to use one in a long time. And this will give the level of salts within the water. Even fresh water will have a level, could have a level of salinity in it. Fresh water does not mean it's totally void of salts. And the species that do require salinity rising slowly as they age or throughout their whole lifespan, this is a really important measure. Many will find it strange that I don't include GH and KH, but they're not recorded, and I think that's because of a whole other load of reasons that it's not really used as a measure unless there's probably levels of pollution. But even then the pollution will tend to be turbidity, which is how clear the water is. So you could say black water has a very high turbidity. So, and then there's stuff like whether it's containing heavy metals, etc. really. And human waste, bacteria is measured depending where you live. If it's a drinking water source, then it will likely be measured. So now I'm just going to talk about a different part of really understanding the fish. So this is actually understanding the fish you're keeping. Not many people really look into their fish and think, oh, it looks like this, maybe this is how it should be kept. Maybe it relates to its adaptability in the wild. So the morphology, which is the physical how a species looks or an individual looks, is a direct result of the fish's environment. A species evolves due to the environmental pressures and the competition from other species. So species do not exist with others of the same niche most often, because as they're in direct competition, one will go extinct, which is why invasive species are such a big problem. So a great example is catfishes are adapted for low light levels, and they often prefer it. They feel safer in that kind of space. They sometimes prefer tight spaces as well, which are often darker. Barbels are what catfishes are really named after. Not all have them like substantially, but all seem to have them in some level. And along with the lateral line, which is a line that goes down the middle of the body, so on here, it will go down here and it will contain several pits. It can stop early, so it might not be down the whole body, and this allows the fish to sense movement and changes in pressure. So both of these allow the fish to sense the world around it. They allow it to see when it's dark. It's not easy to see there. And there's other parts like Ancestors have those massive tentacles, and they could help the fish actually feel its way around the rocks when they're in very tight space, especially when the females display them as well, such as in Ancestors ranunculus, where the females and the males both display quite substantial tentacles, and they're not largely that sexually dimorphic like other Ancestors, which might not be in these habitats. So catfishes are really adapted for dark environments. Many haven't, like, there's a few species that actually have lost their eyes altogether, and there is a species of Ancestors called Ancestors cryptopithalamus, I think it is. And there's also a species of Callichthyidae or Corydoras, I believe, which is has evolved for caves, and the Trichomyceridae, whatever, yeah, so, and the catfishes have the most superior tastes in that category, vertebrates. They can taste a lot better than other animals can, and they see their world with it. You can find food, you can find your neighbours, you could know what your neighbours are saying, thinking, because everyone releases chemicals like stress chemicals and stuff like that, which we probably can't pick up on, like in our environment, but no doubt they can pick up on others. So especially social ones will pick up on others of their own kind as a sort of trigger. So you could also look at where the barbels are placed to work out what they mean and what they're used for. So where the barbels are facing down on a snout, that's known as an inferior mouth, which is facing down, like Corydoras. This might suggest that the species is sifting through something, rooting through something. It's eating off the bottom, so it's not going to be, it's likely not to be a real sort of predator. It's likely to be eating invertebrates off the bottom, sifting through the substrate. So then a fine soft substrate would be beneficial. They're unlikely to be rooting through rocks where they wouldn't want those barbels. They'd want something a bit more robust. And there's fish with smaller barbels, might suggest that they're not rooting through. There's pelagic fishes which probably won't be rooting through anything at all. More streamlined fishes such as Pangasidae will do best in an environment with a lot of space. They're like tuna, they're pelagic fish, they want space to swim, they're social. And the social you might not see in how they look. It's very difficult, I think, to understand whether a species looks social or not. But then it's going to not want to hide. A lot of people get caves for fish that don't need caves, so probably shouldn't be given caves. If they're hiding them, it suggests something's wrong. There's also dorso-ventrally flattened fish that are going to want a lot of high flow. These fish are designed to sit on rocks when rivers are gushing water past them, and they're going to likely be eating the things on the rocks. Especially if you look at the mouths of Loricariidae, they are very indicative of what they're actually doing. So the carnivorous species like genus like Scobenensistrus and Pseudocanthicus are quite long. They've got quite good teeth to pick at things. So yeah, but anyway, just look at them all. Anyway, thank you for watching. I might do more videos like this. I want to do a sort of tour of my fish eventually. And also maybe houseplants if people want. Now I do collect sort of philodendrons, monstera, particularly aroids. I also have ginkgos and stuff like that. And I do want to collect more cycads as well, but it really depends. Anyway, thank you for watching. Anyway, yeah.